Good afternoon. Thank you for joining us today. Carasoft Technology would like to welcome you to our ServiceNow webinar, Integrating SBOM and Vulnerability Response for Enhanced Resilience. Joining us today from ServiceNow, we have Jason Beelan, Federal Solution Sales Executive, and Pete White, Senior Advisory Solution Consultant in Security. Before we get started, I would like to quickly go over a few housekeeping items. Please note that all lines have been muted to reduce any kind of background noise during the presentation. If you have any questions throughout the webinar, please use the Q&A feature on the bottom of your screen, and we'll do our best to answer by the end of the presentation or follow up with you offline. This webinar is being recorded and a copy will be emailed to you. Just to tell you a little bit about Carasoft, we are a trusted government IT solutions provider supporting public sector organizations across federal, state, and local government agencies, including education and healthcare markets. At this time, I'd like to hand the floor over to our speakers. Jason, the floor is all yours.
Thank you, Sarah, and thank you everybody for joining today. Today, Pete and I will be discussing SBOMs and how they are an important part of reducing the risk agencies face in this ever-changing cybersecurity landscape. Next slide. This presentation may contain forward-looking statements that reflect the current beliefs of ServiceNow and are based on current information available. These forward-looking statements should not be relied on making software purchasing decisions. Next slide. So the agenda for today will be, what is an SBOM? Why SBOMs matter? The regulations around SBOMs? How do SBOMs and software development relate? Throughout this conversation, Pete will be showing some slides and going into a live environment. So that's going to be the demo portion of the conversation today. And then we'll wrap up with questions and answers. Next slide. So what is an SBOM? Simply put, an SBOM is a machine-readable list of package dependencies, files, licenses, and other assets, together making up a piece of software. Think of it almost like an ingredient list, but for software. And software consumers have increasingly depended on external third-party software components to perform critical functions with little to no visibility into the code of these products. The lack of transparency is the core issue that prompted the need for SBOMs. And component vulnerabilities are a prime source of cyber risk in the supply chain. SBOMs are designed to identify these risks, allowing better visibility and swift mitigation. Next slide, please. So SBOMs aren't a new undertaking. Their history goes back well over 10 years, but recent events, including SolarWinds and Log4j, have shown how SBOM can be a vital tool used to understand what software is in your environment. Next slide, please. Over the past couple of years, the White House has released several memorandums, including M2218 and the updated M2316, enhancing the security of software supply chain through secure software development practices, even to the point where CISA released guidance earlier this week on software transparency in SaaS environments, and they're looking for agency adoption for bringing in SBOMs from your SaaS vendors. Next slide, please. So challenges we see when we talk with customers really around how do we store SBOMs that I'm getting from our software vendors and internal development teams. If you think of the magnitude of SBOMs an agency should be collecting from all of their software vendors, including dot releases, multiple versions of their software, how do we manage it and access it? How do we search the contents of a machine learnable or readable file? That's going to be a challenge. And then can we match the content inside SBOMs with known vulnerabilities? And how do we turn those vulnerabilities, if we find them, into actionable items? So this is where you can go from having a more of a compliance-based SBOM storage program to actually having actionable way to be able to read SBOMs and then determine whether or not there's vulnerabilities in there and take action on those. And we'll talk about that today too. Next slide, please. So SBOM management. So really non-relational databases, they're going to be a lot more flexible. However, it makes management incredibly overwhelming. So if you look, it's just file store, and how do you find things that are not indexed and cataloged? Where ServiceNow, we're a relational database. We organize the data in interrelated tables, making it much easier for an organization to manage data for effective use and be able to use those SBOMs in an effective manner. Next slide. And then ServiceNow has developed SBOM capabilities into our latest version of vulnerability response. This is to help agencies not just meet, but exceed the requirements of M2218 by making SBOMs actionable. Now I'll hand it off to Pete, and he'll be going through some of the technical and the demo screens.
Yeah. So when we start looking at software in the modern digital world out here, most modern software is built using packages from a number of different sources. It's not all homegrown from the ground up type of development anymore. You're pulling packages from, some cases, these packages might come from some questionable locations, or in, more concerning, have a limited support for the package that's being done. In this example, in this little cartoon here, is you have a very critical piece of this particular application that's being designed or being maintained by this person in Nebraska. Not there's anything wrong with development in Nebraska by any means, but building an entire piece of your critical infrastructure on something that, if something is wrong with it or you need an enhancement to it, and depending on that one person to fit that into their schedule, is a lot of risk that you're bringing into the environment. What we saw is there was actually a report done by Synopsys last year where they went through and looked at over 1,700 different code bases that they could do the analysis on, and they found that 96% of them contained packages that were from open source solutions. So this is not something that is a minuscule problem in the industry. This is essentially everything that's being developed today has some kind of an open source package that's being included in it. And then within those, they found that a very large 91% of them actually contained abandoned or outdated components. And the definition of abandoned can vary from location to location. We have one for our technologies. We'll talk about it here shortly. But anyway, it's something that has been, was something that had not been addressed or been developed on or released a new version in a long time. Let's put it that way for this discussion here. And when you start looking at supply chain and software supply chains, the effects that an issue can have can have astronomical effects on the organization. Something that you think about like a browser. Obviously, there's lots of browsers, something we use every day. And you may assume that Microsoft developed their browser Edge entirely on their own, and it didn't really have anything back there. But you look at it in reality, you start backing back in its history. It has Chromium, and same as Google Chrome is all based upon that. And then they have development pieces beyond that in the mix along their way, and other dependencies that grow into this. So one simple kind of one application here, there may be 10, 20, 30 different upstream effects or upstream pieces of that supply chain that you need to be aware of and understand the effect it's going to have on there. So something simple as an issue with maybe the Blink rendering engine, a couple levels back up, essentially means you're going to have to cause an update to your entire environment around your browser to address that vulnerability. And so these kind of simple things like that. If we learn anything from like Log4j, not to keep kicking that horse, but it's that a vulnerability way up in the supply chain can have dramatic effects. Previous slide there talked about the number of hours and dollars that government agencies spent on addressing those vulnerabilities within the organization. And this one's just an example of a browser. It could have that same kind of effect, and probably even bigger because it affects more of the organization. And before we dig into the actual SBOM itself, I think there's some foundational pieces that we need to discuss. So when we start talking about vulnerabilities, there are multiple types of vulnerabilities that are within an organization. The most common you'll see, and ones we're most familiar with, are what we call infrastructure vulnerabilities. These are the ones that are located by your vulnerability scanner, whether Tenable, Qualys, Rapid7, whatever the solution of your organization is using to do those vulnerability scans. Those are normally handled by the asset owner. If it's a Windows device, a Windows server, the Windows team is responsible for getting those patched. And generally speaking, there's a pretty defined process for getting the vulnerability information to the right teams and getting those patched. It may not be the most efficient. It may involve, Excel spreadsheets and email, and we have solutions that can help you with that. We'd love to talk to you about if that's something that you're concerned about. But it's a pretty well defined and easily, documented way of doing that. The next kind of vulnerabilities that you run into are really misconfigured asset vulnerabilities. You may have the most up-to-date patched system out there, but if the password policy on that server doesn't have one or doesn't require any kind of a complex password, well, it's just as vulnerable as if it had a ton of vulnerabilities in there, maybe even less, more easily exploitable because of that. And so you have those configuration scans. You're looking for those policies. For those policies like password policy I mentioned, things like that. And, normally whenever a new software, a new server is rolled out to an enterprise, it normally has a kind of a gold standard that was applied to it whenever it was first rolled out. But over time, we see these drift in those configurations, and so doing these configuration scans, looking for those that drift and making sure those are applied. And once again, it's generally the asset owners that are the ones that are responsible for getting those done. If a password policy needs to be changed on the Windows server, the Windows team or maybe the Active Directory team or someone is usually the ones that are taking care of that. When you start looking in the last area, which is application vulnerabilities, there's a different process that follows to that. It's using a different scanner. It doesn't use the same infrastructure scanners. There are specially scanners that are designed for doing these application scans because it's a different type of code base or different type of environment you're working with there. And what's unique about this is that the person who's responsible for getting those patched, particularly for internally developed application, is your development team. It's not the infrastructure team, it's not the Windows team, it's the development. And you have to make your systems and these processes fit with their continuous integration, continuous development tools that they're used to working with. They have a process for developing and putting software patches into sprints. You need to work with those and make sure that you are working in those environments as well. So the way that these application vulnerabilities are determined are usually there's kind of three different technologies that are used for these types of vulnerability scans. Dynamic application security testing, or DAST, is doing the vulnerability scanning while the system is running, usually in a dev environment. It could be production, depending on what you're doing in your world. But it's running it it's testing it while it's running on a server. It has internet connectivity, all the standard stuff that like a user would be interacting with it. The second type is static analysis or static application security testing, sometimes referred to as reverse engineering as well, where you take the actual binaries or executables or packages and run them through a reverse engineering engine that will take and tear the pieces apart and do the evaluation on the individual pieces, looking for vulnerabilities that way, sometimes called white box testing as well. The third type is software composition analysis, and this is actually taking a look at the code base and determining vulnerabilities there. And this is where SBOM fits, is in the software composition analysis area. So we are taking and looking at all the components, the licensing, all these things, and looking for those individual vulnerabilities and exploits. So let's actually dig into our solution here. So the first step in the process is to ingest, bring in those SBOMs. Instead of having them out on some file share that Jason out, that you really don't have anything out there and you're just kind of a click box compliance or whatever, or checkbox compliance. We want them to have actionable information. So we bring them into our system and allow them to get additional, make them so it's readable by a human that way. There's a couple of different ways that can happen. There's automated APIs available that you can push them to the workspace and allow them to be addressed that way, or we can do a manual upload. Within the API stuff we're designed to work with those CI/CD tools, such as Jenkins, for example. So whenever a new version of a software is built, that SBOM is automatically generated and gets pushed up to the workspace and for evaluation to look for the various different items we're looking for here. We have integration with Veracode as well. That's a vulnerability scanner. They can generate SBOMs, and we can get them from those as well if you're if depending on how you're doing your development that way. Like I said, the most common way is going to be a manual upload. Some vendors are making their SBOMs available through their portals. And so you would simply go out there, download it to your local machine and upload it, and then walk through uploading it to the workspace. And I'll show you what that looks like here in a second. The bombs themselves, we support the most common methodologies out there, the Cyclone DX and SPDX. So we have full support of that and would allow those to get uploaded. So let's take a look at the actual console itself. So we have a purpose-built workspace called SBOM Workspace. Within ServiceNow, we've started coming out with a number of these different workspaces within the tool. They are designed to be used by the different personas that would be utilizing these different pieces of the organization and within the applications here. So within here, we have what we call a BOM queue, and this is where we're going to upload these bombs in the mix here. So it's simply, if you have a file, you click on Upload BOM. It's going to go out here and it's going to say, okay, I need to select the file in question, go out to your local machine, wherever it is, select the BOM that needs to be uploaded, click on Open and Upload, and it's going to stage it for processing. And so I've already done this, so I don't need to do it again, but I would simply click on Upload and it would go through and process those files. You'd see here in the status as those come up here that we go through processing and then eventually processed. So once we have the application processed, the result of that is that we get a much more easily understandable view of the contents that were contained inside of that SBOM file. The first one is the components, all the different pieces that went into this particular application. In this case, the application was a Java application. Excuse me. It had a number of components out there. Within the individual components, you can see the type of the classifier within the SBOM that's defined as a library, the version information, the licensing information, Apache, MIT, open source, whatever. And then most importantly, or one of the most important things, is this package URL or Perl location. Essentially, this is the kind of a unique way of showing it, but essentially is the URL to where you downloaded or where they got this particular package for including in the application. Once we actually see this information, we can dig into the actual components and learn more about them as well. So in this case here, I can open up one that was in that listing here, and I can see that the state here is vulnerable. We'll talk more about that here shortly and how that became about, but I can see the version information. We kind of knew that already from the 145, but not all components will list the version right there, so you may need to know that information. We can also see the latest published information here, and then how far back we are from the latest one. So if we're using this software in our environment here and you're 22 versions behind, that's probably not quite ideal. And you can get over here on the right-hand side, you can see all the versions. This is the version we're on here, and here's all the versions that have happened since then and up to the latest and greatest version available for this particular component in here. The next thing we can look at here is the dependency graph. So in this case here, this particular component is actually something that is used and dependent upon by these two other components down here. And this is kind of a simple example here, but some of these graphs can be very large, that we have something here that's something that's used by this, that's used by this, used by this, and so it can go down here. And having that full view of the effect that a vulnerability in a particular component would have is something that is generally very hard to come about, and that's something that would be very difficult to understand or deduce from that JSON file that the vendor gave you along the way here. We have hash information. If you need to go verify that you're using the right one, that information's there. This is information that's contained in the SBOM as well. And then we can see, and it's actually a little easier to see here, is the number of actual bombs that we have uploaded that actually had this particular component in here. Now, in this case here, I've only got a handful of SBOMs that I've uploaded, so these are all only available in one. But if you think back once again to that log4j, understanding and knowing that log4j was in 20 or 30 different components or different applications in your organization, by simply looking at that process much easier to work with and easier to develop with. Okay, so now that we have the information in there, the next step in the process is to determine and assess our risk within the organization. So we can bring in open source security intelligence, national vulnerability database, things like that. And oops, wrong way. Come on, there we go. And understand, do we have components that are contained in this application that have a known vulnerability to them? So we can see, does a CVE exist for that? We bring in CISA KEV information as well. And so if there's a CISA KEV record for this particular component, that needs to be concerned and addressed as well. We have integrations with Sync. It's another vulnerability scanner out there that allows us to bring in additional information, particularly from cloud-based applications that, as things change that may not have been an initial bomb, they can find stuff and they can bring it in there as well. So that's additional integrations we have. We have a lot of integrations to our products to enhance and bring additional value to the process here. So looking back at our screen here, so now that we have brought the data in, the next thing we're going to do is do that vulnerability. So I can click on, and we have that vulnerability listing here. And so I can see that the component in question, the vulnerability that was determined for that particular version, the CVE information, a summary of that vulnerability. And like I said, in case there is a CISA KEV value for it or not, we see that information here, true or false. And then if it is true, the actual CISA KEV, the CISA due date for that to be addressed. And so you have that information very easily addressable and quickly do it. And this would be something that would be very difficult to do manually, to go through all the components that are contained in those SBOMs and manually check them against the CISA KEV or the CVE information from the National Vulnerability Database. So it'd be very hard to pull that information together in a somewhat readable format in a quick manner if something was to happen here. So now that we have the components that brought in, we've looked at the vulnerabilities, we can take and look at the environment at a much higher view as well. So in this case here, I've only uploaded a few of them, but you can see the number of components is quite large. 1,700 different components in just a small number of applications. So the number of components that are involved in your organization can get very large very quickly and could be quickly hard to understand here. But what's important is that I can get some statistics about this. I can see the number of these components that are stale. And our definition of stale is something that the version that's being used is at least 2 major versions behind the most current version. So whatever version, if you're using version 1.1, that there's at least the product is at version 3, for instance. So we're a couple major versions behind is they're using a stale version of that. The bigger concern one is an abandoned component. This is something that hasn't been, our definition of abandoned is something that hasn't been touched or updated in more than 2 years. So if there's a vulnerability in that particular component, getting something patched for it, getting that vulnerability resolved is probably going to be pretty hard, if not even impossible, depending on who was doing the maintenance of that and keeping that up to date. And we actually can build out some of these high-risk combinations here. So in this case here, we have an abandoned component that has a high or critical vulnerability. So this is ones that are the vulnerabilities are higher criticals, and we could dig into those and see which ones they are. And then, what the hopefully the number is, the abandoned vulnerable is actually completely fixable is actually equal to that. So with these completely fixable ones, these are ones that a later or newer version of the component would address all known vulnerabilities out there with that component. So these are ones that we can just by utilizing a more recent version of the software, we can address those vulnerabilities entirely. Okay, so now we've seen that we've got the data that's come into the environment. We've gone through and compared it to the known vulnerabilities that are out there. And of course, this is an ongoing process. I mean, you upload it, and it may not be a vulnerability today, but tomorrow one comes out. So we're always keeping this data up to date, and we will, those statistics will change from day to day. But now the question is, if you have a vulnerability, what's the next step in the process is to get that to the right team? And this is where we get the response piece here. So this is building on our application vulnerability response solution, which is part of the vulnerability response product within ServiceNow. And the first step into that is to prioritize the risk, figure out which ones need to be addressed first, create findings, essentially create a tracking mechanism for determining for tracking these vulnerabilities throughout their life cycle till they get patched, getting the triage workflows, getting them figured out who needs to be responsible for getting these systems patched, getting it to those teams. And then once that package has been updated, that software, that application is now an updated one, we need to update the SBOMs and get those put back into the system again, and once again go through this whole process again, because every new version of a software package needs a new SBOM because something has changed. It's not just every major release needs an SBOM. If you've made any change to the environment, you need to update the SBOM. And so once again, as things happen in our ever-changing, always new development world, keeping track of all those SBOMs is in making sure you're utilizing the latest one is definitely something that a lot of our customers are concerned and have an issue with. And so how's that process go as far as prioritizing those vulnerabilities? Well, some of it depends upon the exploit data itself. I mean, is it something that's simply exploitable, very trivial exploit? That's going to drive the risk factor with that. Information in the CMDB, you run this application runs upon the ServiceNow platform. It has a CMDB built into it. We know information about that application, the criticality of that application, the upstream and downstream effects that application has within the organization, and that will drive and prioritize that information as well. So we can, and then that will drive the development team to address these vulnerabilities. And of course, I mean, obviously there may be regulations that you're dealing with as well, such as CISA that you have to meet as well in the process here. So how does that work? Let's go back over here and look at our console here. So we went over here and we were looking at I go back over here to my cube, my shopping cart here. We had our vulnerabilities in here. The next thing in the process is we're going to create AVIs or AVITs, application vulnerable items. If you're a ServiceNow customer, you may be familiar with the idea of a VIT on the infrastructure vulnerability side. These are application vulnerable items, and so we are going to create one based upon your definition of things that need to be addressed and the criticality for them. What we do is we create an AVIT. Come on, move my thing there. AVIT creation rules. So in this case here, I've got a couple that were created. This one here, I'm looking for some components. I'm looking for log4j. I'm looking for DCOM. I'm looking for whatever it is out there. And if I find any of those, I want to create an AVIT for it and things like that. The more common ones is you're going to be looking at it based upon a critical or high vulnerabilities that are impacting the application. So we're going to create an AVIT if there's a critical or high. Well, I'm going to actually create a new one here and kind of show you what it looks like. Is we're going to do one based upon a CISA finding. So we got a CISA vulnerability execution order just determines which one runs first. So if this is the one I want to be the first one to run, based upon that, then I would change this down to a lower number than the other ones. For now, it doesn't really matter. This one here, I'm going to just do vulnerabilities. that have a CISA CAV record. And so now I'm going to go down here in my conditions. What things am I looking for to determine the creation of these AVITs? The first one here, I'm going to go here to the vulnerability, and I can see that I have a CISA CAV. And if it's true, then we're going to create an AVIT based upon that information. I would simply click on submit, and we're going to go back over here to the things. And now I have this CISA CAV in place here, and it would start running and creating AVITs based upon CISA CAV findings in there. And we can look in the actual AVITs themselves. We can go over here and click on one, dig into them, and this would have, risk scores associated with them. That's part of the application. Vulnerability response application is to assign the risk score, the risk rating, the remediation target. We have remediation rules as far as how quickly these systems need to get patched. So you can track, and it's not just something you throw over the fence and wait for the development team to get around to it. They have SLAs or targets out there that they're trying to meet based upon like I said, regulations and stuff in place here. Where it is in the status and the vulnerability here. But I can open up one and take a look at it, and we can see that once again, some of the same information we've seen before: the licensing information, the version information here, the application. But what's really important here is the fixed versions. So we know the version of that software that that fixes those vulnerabilities, and so they just need to start using that one. They need to put out the utilize that for their next version of the software. So we provide this information. This information would get passed over the development teams and allow them to start getting these systems patched. So with that, I'll turn it back over to Jason to kind of review, and we'll go from there.
So we covered, how do you store SBOMs, and really the best way is in that relational database. How do we search the content of a machine learnable SBOM? So we covered that. And then how do we match the content inside the SBOM with known vulnerabilities? We covered that. And then how do we turn vulnerabilities into actionable items? So we covered all 4 of those areas. I see there's some questions in the Q&A. So I don't know if, Sarah, you want to read those off and we'll run through those.
Sounds good. All right, first one I have is, how can I validate I have SBOMs for all of the software and versions in our environment?
Thanks, Sarah. That's actually a really good question. And the challenge is, there could be thousands of different versions of software in an agency, depending on the size, different dot releases. So the vulnerability response solution does not do that, but we have software asset management. So with software asset management, you can go out and be able to bring back all of the licenses in your environment. It's not just for security purposes. You could do license rationalization, things like that. But the key is being able to bring those licenses in and then compare those to the SBOMs. Right now, it's a manual process. There's a roadmap item where they will do the matching for you, but it's a start where you can start seeing these are all the versions of software I have. I've got maybe 999 different versions, and I've got 800 SBOMs. We know we're missing some. So eventually it will get there where it will match those together, but it's still a little ways off, but this is a good start.
Okay, and then the next one, how do you define licensing policies to align the usage with the legal department guidance? For example, identify licenses that are not supposed to be in use because they're breaking the license agreement.
I think that goes back to the software asset management, because it would do dual purpose. So leveraging software asset management, you'd be able to bring that in. You can compare that to the licensing agreement you have with said vendor. And then I think that helps there, but then also helps with the SBOM correlation and making sure that you've got the SBOMs for that software.
Okay, can the system augment the security risk by getting results from other SCA tools like Black Duck and dependency check?
Pete, can you answer that one?
Yeah, if I understand the question, the answer is yes. Yeah, we can bring in additional sources of data to within the SBOM to help with that. We talked about like Sync and some of these other ones out there. I'm not. I'd have to go back and look and see what we have as far as Black Duck integration. I think there is one, or some. It's definitely something we've talked to about coming out with one. So I think it's in flight, but if it's not there, but yeah, so the ability to bring in additional information from other sources, that's part of the idea behind this, is that you can bring those in and utilize them as needed as additional sources of information for determining risk and methodologies for addressing that. So yeah.
Okay, I have another one that how is this licensed?
So it's licensed with our traditional VR vulnerability response licensing. So it's a component with inside our vulnerability response for the versions of professional and enterprise. Has the ability to bring in SBOMs. We're more than happy to get on a call and discuss that with the person who asked the question. So feel free to reach out to us, and we'd love to talk to you about that.
Do you need to rescan to get new CVE impacting those components?
No, the CV information gets uploaded automatically. We're pulling that stuff down, that information down from National Vulnerability Database automatically. We utilize it in multiple places within the platform. And so as new vulnerabilities come down, then we compare that to existing information we already have, and we'll update that based upon new information. So no, it's automatic, part of the process.
Okay, and then we have one in the chat. Can you use attack surface management tools to find out if the same software vulnerabilities that exist in your SCA tool match the ones you see in your attack surface?
I'm not sure exactly what you're asking. Can you be a little bit, when you say attack surface tool, what are you referring to? If you can.
Security scorecard.
Let's see here. Can you use attack surface? So I'm not quite sure exactly what you're going with, but I'll address it this way: is that we within with ServiceNow has a similar tool, and I think what you're trying to get to is we have a newly released product called Security Posture Management that will take information from that we're getting from our various different service graph connectors into the CMDB and allow you to search and say, okay, I need to know what version of this application is running and things like that. And then, if it's not running the latest version or it's missing that endpoint product on there, whatever the case may be, to result in a finding. So we have that integration there. The integration, or the speaking of the security posture management and SBOM, there's not anything there today, but we're always looking for additional ways that products can talk together and make a better story together and connected tissues. So I'm not saying there's not something on the roadmap. We haven't got that today, but the ability to do some of that stuff seems like it would be something that would make sense, and could, something that we definitely for feedback to our product management team for sure.
Okay. And then another in the chat pod, licenses do not necessarily include version information, especially if they're for a perpetual license. Do you have any other helpful solutions for that?
So perpetual licenses should have different version numbers based off of the dot releases. So anytime you've got, maybe it's Microsoft Office, and there's always going to be a dot release for that, or you name it, Adobe's going to have a different version as the software gets upgraded. And that they should be sending SBOMs for every single dot release or anytime the software does change. Hopefully that answered the question. I don't know if there was more.
Okay. And then we have one more. Does SBOM give bad actors the information they need to find vulnerabilities in our software?
So this is a question that has been around since the beginning of the SBOM discussions, and the answer is no, it really doesn't. A bad guy is, or a bad actor is going to find the information around software if they want to. The FBI released a reverse engineering software a couple of years ago that allows to do this same kind of work we talked about, with the SAS and DAST before. So there's a number of tools out there that if the bad actor has access to the executable thing, and then they can, they'll have access to ability to tear it apart and understanding it. So this is not opening up any additional vulnerabilities in the environment. You're not losing your intellectual property. You're just simply saying that, very similar to, your food, you need to know what's in your food. We need to now figure out what's in our software. There's been too many major breaches out there that people didn't understand what was going on to their software, and this is just a reaction to that. Same reason they put in the food requirements, the FDA did for building out what's in our food. We need to know what's in our software, and so this is really designed to allow that to happen and allow you as a vendor or as an application purchaser to know what's going on there and be able to handle and address vulnerabilities that come up, because we know they're going to happen. And so we don't want the fire drill at Christmas like we had with Log4j a few years ago. We want to know what's there and be able to handle it appropriately. Jason, any other comments on that?
Yeah, no, I mean, I think that's spot on, and even we had Dr. Alan Friedman from CISA speak at our Fed forum, and he addressed this subject matter-of-factly, and, it very similar. The bad actors, they'll be able to reverse engineer your software, but if you understand what's in your software, it gives you an advantage to see where the weak points are or where there is abandoned software. Today, without SBOM, you're really relying on somebody be able to understand that, and leaves you at risk for a 0-day type of attack. So having that ingredients list is going to be vitally important. It's one of those things that they're requiring software vendors to provide to agencies. So leverage it. It can be something that you store and just have, or it can be something that can increase your security posture. So we hope that a lot of agencies adopt it and they start using this to increase their security posture as a whole.
Okay, well, I'm not seeing any more questions come through. I'm not sure if anyone has any more.
Well, I want to thank you for your time and attendance. If you have any questions, please feel free to reach out to us. We're happy to discuss and do a more in-depth demo if you'd like to, but I appreciate your time. Jason?
Yeah, absolutely. Thank you so much for attending. There'll be some information that gets sent out post this Tech Talk. They'll have a little bit more information on SBOM with our contact information. If you have any questions on licensing or some things that we didn't address in the Q&A or didn't come up, feel free to reach out to us. Be happy to have a conversation with you.
Thank you, Jason. I'd like to thank all of our participants as well as our speakers for being with us today. We hope the information you received during this webinar has been helpful. If you have any further questions or would like to request more information, please feel free to reach out. Thank you again and have a great day.